but I want you to be able to see all the stuff that's written in a way that you've never seen before. That's all I'm doing. So let's have a look at this one here. So if I tell you I want to get the integral of a derivative, let's forget about the 2 and the 4 for a moment. What does an integral do to a derivative? What does derivative do to an integral? They undo each other, they get rid of each other. But let's go through and actually do the question for a moment, just like the fundamental theorem of calculus. So on this one, if I differentiate 5x squared, I end up with 10x. And what happens to the 1? The 1 disappears. So that bit there being done is just 10x. So you've still got the integral of dx. And of course I can still say I want to do the 2 to the 4. So then what happens when I get the integral of 10 to the x? It puts it back to where we started from, which is a 5x squared plus a c. So there's the basics of it, which is the fundamental theorem of calculus, not in the way I really nagged about before. But then if we put values in, the 2 and the 4, so here's our 2 and the 4, what do you do with the 2 and the 4? You substitute them in down here. So let's have a look at what we end up with. So we end up with a 5 times a 4 squared minus, and the c's you don't write because the c's are going to cancel out again. So even though a number will come back into here, they eliminate each other, they cancel each other out. And that's a 5 times a 2 squared. So there's our actual calculation. Let's have a look what happened again. The integral and the derivative are the opposite of each other, they cancel each other out. You're left with a 5x squared. And then we're going to substitute the 4 and the 2. Now if you substitute 2 and the 4, it wouldn't matter, you're just going to get them the other way around, just be careful. This is the top minus the bottom, the upper limit minus the lower limit. And you end up with that. So what we're basically doing is putting that value back into that function. So now when I write it algebraically like that, you can't see the function. So if I gave you that question to do, to me that's common sense. It's what should be written when we're not trying to trick people. But when it's written like this, we're trying to trick people. And then people will say, well, it's testing your understanding, but I think it's just trying to trick people. So what does an integral do to the derivative? Gets rid of it. And we're left with just the function. Now, this plus 1, just like over here, it disappeared. Then it will come back as a c. So I could have written here that's an fx plus a c, and I can go, now we're going to do the integral of that. Oh no, sorry, I mucked up. Now we're going to just look at that, and there's the answer to the question. So what did the integral do to the derivative? It eliminated it and come back to here, but we wouldn't know what the value is. But when I put the 2 and the 4 in, then we're going to substitute that here. And what happens to that c value? Just like that c value here, it does nothing. We don't even need it. So all we're doing is substituting the 4 value into the function and the 2 value into the function. So well, like here I've substituted the 4 and substituted the 2. Let's go back to this again. I'm going to say it one more time like this. So what does an integral do to a derivative? It leaves the inside the same. Now I could put plus 1. Maybe I could do that because it won't make any difference to the question. Like let's say I did do that and I wrote that as still as a 1 instead of as a constant. But then I know I'm going to substitute the 2 and the 4. And what happens to the 1? They're going to go 1 subtract 1 and they're going to disappear. So all I'm going to end up with is f of 4. And then I'm going to subtract the, oh actually I'm going to write the whole thing. The f of 4 plus 1 minus the f of 2 plus 1 with brackets around it, and the brackets again, and those ones eliminate. So all I'm going to end up with is f of 4 minus the f of 2. Now if you know that if they tell you up the top, by the way, f of the 4 is, say, I think I 10 again, and let's say f of 2 is 6. So what are we going to end up with? 10 take 6 is just 4. So I hope it makes sense. It's just, again, if you look at it, it's a mucking around where it's functions, where you're doing what you've normally done and you wouldn't do without any hesitation, but they just make it look different. So at the end of my videos, I'm going to start putting this. A lot of people keep on saying, can you make extra videos on calculus, on trigonometry, all sorts of topics, factorization, and I want to just briefly show you a quick look at my channel here. So if you scroll down, you have year 7, class 7, and I've got this click here, so you can go across and look at a lot of the playlists, but often I have more playlists than what Google will allow me. Covers a lot of topics. So that's class 7, year 7, grade 7, first year of high school for a lot of people. Then class 8, there's a lot here. Now by the way, if I do click on that, you get an idea of how many playlists I've got. Oh, there's so many.
equations, rates and ratios. It goes on and on. Now, a lot of my videos I have them in logical order, so once you open them up, you'll see there's a beginning, very basic video going through to the harder concepts. So then you get the year 9 and 10. Now in Australia we have this unusual situation where year 10 splits up into two groups and we have an extension or an advanced class. So I've got a separate section for 9 and 10 which doesn't quite go so far as the 10A. So each of those go a lot further, and then you have at least lower level. Oh, by the way, I've got this one here. If you have a look at this one here called 1 Minute Maths, the 1 Minute Maths themselves are fantastic and helpful for people if you want to have a look at them. I've also got this, my recent best videos. If you want to help me with my view hours, which is what I really need help with, is if you go through and play some of those and leave them running and press like or make a comment or just watch them for your own sake. That's a really good way to get it going. I'll add more to it. Now we have a low level course called Essentials in Western Australia, and then we have one that's slightly academic called Applications. You can go look at the topics later. Then we have this, well, not unusual, it's probably the same in a lot of countries. We have a double maths. So if you pick the highest one, which is called Specialist, you got to pick the next lower one down, which is called Methods here in Western Australia. So if you have a look at the topics, this has got calculus, differentiation, factorisation and graphs and all sorts of things. Of course you can click here and you get a lot more videos. Then it gets really serious, and that's called this Specialist Maths. That's where you, if I click on here, that's where you're getting logistic models, simple harmonic motion, 2D, 3D, vectors, complex numbers. That's the serious level maths. A lot of it applies to students at university, especially students in first year engineering, and they hadn't done the highest level when they were in year 11, 12. A lot of students are finding it very helpful there. Again, if you can get me some view hours on things, that would be fantastic. Thanks for watching. Bye for now.